So we are going to have an excellent session now. So before I move on to the session, I just want to introduce about myself. So I'm also Vice Chairman of Indian Electronics and Semiconductor Association. If you have a look at my presentation, so I will quickly go through the IESA vision and goals. I mean, in terms of what we do at IESA, which is Indian Electronics and Semiconductor Association, our goal is basically to help the industry grow electronics and semiconductor business in India, become a go-to destination for electronics and semiconductor for design and manufacturing. So as IESA, we have been closely working with government, both at the state level as well as the central level. And we have played an important role in various schemes which government has come up, whether it was PMP in the past or PLI, which has been coming, the PLI in different forms. It started with the cell phone PLI, and now we are having PLI in different areas, different end equipments coming in. So we also play an important role in the academia. I mean, we work very closely with different IITs and engineering colleges, and we are trying to bridge the gap between the requirements of the industry and what the academic colleges are offering. So in terms of, I think I'm going to spend more time on this particular slide, which is basically talks about the ESDM industry. If you see the ESDM, there's constantly going to be a big gap between what we produce in the country and what the demand is. And the demand for ESDM products is going at a very high speed in India. It's going at a 21% CAGR growth, while as the whole worldwide growth is around 5%. In fact, it's less than 5%. So if we go at this pace, and we have been talking about for many years, the ESDM import is going to basically far exceed what we produce in the country and far exceed the oil imports. What we have seen is we worked with Frost and Silver and IESE, and we came up with a paper, and where we basically saw that the gap between what we produce and what the demand is, despite having so many schemes, whether it is PLI or PMP, the gap even in 2025 is going to be $100 billion, which is a big number. And what we know, because of the schemes, whether it is specs or PLI, this gap will probably come down because of the introduction of the new policies. But what we know is, unless we own the IP, both at the semiconductor level as well as at the at the product level, we will not be able to control the global supply chain. And also, what we are producing today in India, the value addition is in high single digits to low double digits. So it's somewhere between 9, 10 to 12, 13%, and which is not a good sign for the whole country. And we had series of discussions among various stakeholders of our member companies of IESA, and we came up with some kind of suggestions on some of the products, at least 8 to 9 products, which are of national importance. So whether we talk about the smart meters or energy meters, whether we talk about the 5G, both at the edge level as well as at the infra level, and smart CCTV and camera. I think all these products are of national importance, and we will hear more from the panel on this, what should be the roadmap for us. I think with this, I basically would like to introduce the 2 keynote sessions. We're going to have 2 keynote sessions now. First by Chairman and MD from Lava, Mr. Hariom Roy, who is going to talk about India with respect to mobile phones from here. I mean, how do we go from here? And immediately following that, we will listen to Sambit, who is Senior VP at Intel, and he's going to talk about how innovation at silicon architecture level is enabling both AI and ML applications. So with that, I basically hand it over to Hariom Roy, who is going to talk about the mobile phones and beyond. Thank you.
I just wanted to share 3, 4 things here. I think we are standing at a historic opportunity for India, which has not been there, which is almost coming after 300, 350 years in the country. And second thing I want to share is to dream big. Third thing is that in this industry, unless there is an ecosystem which is built, uh, the local companies can't do much. But as we are in the process and government is in the process of building this ecosystem, it's a great opportunity. And last thing is that whatever we are going to do, for example, whether it is going to be a chip design coming from the Bangalore ecosystem, it's a great opportunity. But fundamentally, unless government is there to help and support, it is almost like part of building skills for the country for financial and technological independence. Unless that happens, nothing is going to grow big. So that's what is the basic context I wanted to share. So before I go, so let me tell something about myself. I'm a serial entrepreneur. And fortunately, in whichever business we went prior to Lava, there were 3 businesses. In all small businesses, nothing big, but in whichever segment we went, I was fortunate that we became number 1 in the country in those segments. In Lava also, we are number 1 in this segment. So Lava started in 2009. We started, our journey in 2009, and we are present in 20 plus countries. Our 1/3 revenue comes from abroad, and we are a complete 360-degree company, which means we do the research and development in India, the design in India, the complete upstream supply chain, SMT and assembly, the entire retailing and distribution also in-house, and then customer service. So we are probably the only company in the world to have end-to-end control on the mobile phones as a product in India. Most of them have, control in this system. So having said that, despite being number 1, we got badly disrupted into 2018. So today we sell about 1.5, 1.6 million mobile phones in India, but every month. And despite that, I must tell you that there was a huge disruption caused by the foreign companies, and we were underprepared. All the Indian companies were underprepared to, actually fight with this disruption. So when I looked back, I found that the reason why we got disrupted, of course, internally we were weak, and in many businesses we have done very well. The reason we got disrupted is that it is all about ecosystem, and the government must have acted well in this country to build the Indian companies, because that's the only process to progress the country from poverty to wealth. So I realized that it is not happening after I started talking to the government. But then I realized that it is, the Lava's disruption or our industry disruption was the best thing which could have happened to us, because, this is an opportunity for us to build the country and also build companies from India. So to give you an aspect, I'm not going to go into the details of what all happened and what all transpired with the government, but to give you a big picture as to how I learned in the process as to how the world works, I'm just going to share you a high-level picture and what is the environment today, in which environment we are. So this is the process of growth and dominance of nations, how the nations were. This is from 14th century, 1500 to 2000. This is Dutch, and what is the process of growth? So first, as a nation, you start, acquiring technology and skills, and you dominate there. Once you acquire technology and skills, your output becomes very competitive. And once your output becomes competitive, you start doing trade. And because your output is very competitive, and then you go and move to build the military dominance. And on that, you build the financial center. Once you do all these things for a long time, you become a financial center. And then finally, you create a currency dominance. So that's the only process with which countries have grown. So if you see in 1700, Netherlands was at its peak. Then we go and look at about 1850, Great Britain actually finally, dominated. They overtook Dutch and became the world power. Then in 1950, United States became the world's power. And then now you can see how China is growing on the same principles. And what is going to happen in China? In 2050, probably China has the potential to lead the world and change the world order. So because of that, China has become a very big threat to the ruling power USA. And it has happened in the past consistently over the long time. So this is how the rises and declines of great powers have happened. This is India. India was also in 1700, very significant power. Of course, Dutch was ahead of us. Dutch were ahead of us because in 1700 they were ahead of us in GDP terms. But then here comes the Britishers, and they have dominated. In 1850, here comes US, and then you can see now how China is going to come and cross the US. From 15th century, it has happened 16 times that a rising power has crossed the ruling power. And out of 16 times, 13 times, there was a war between the rising power and the ruling power. So when we see the war-like situation between China and US, it is only because of nuclear things that the wars are not happening these days. Otherwise, I would say trade war is just a symptom of a broader conflict. It is a very natural, evolutionary step to establish the world order war. And therefore, no matter who comes in US, no one can stop the trade war because US, for example. Why I'm saying this? Because US is at its peak right now, and at the peak of the United States, they have peak means they are number one in the world in terms of the GDP, 25% of the global GDP, but their market capitalization is 50% of the global market capitalization. And their currency is used, 77% of currency used in the world is US dollar. And their employment is ever lowest. When that is the situation in the United States. The bottom 60% of people have not grown. There's a gap from 1980s. It is growing considerably. And you see a simmering discontent in the bottom 60% of the population. So when China is going to, actually cross US economically, then politically US will face big issues. So therefore, the leader of the US have no option but to hold China in their growth. That's the only way US can grow. US can, curtail the political rift in the United States. So US will try to ensure that it takes as large time as possible for China to grow. And so therefore the point I wanted to make is that geopolitics is going to precede business. So when when in normal situations, the business actually takes the precedence. But these are the special situations. You all may know it. How Huawei is being treated is not because of, in my mind, any security reasons and all these things. These are all gimmicks. Fundamentally, you want to stop, because if you see, China has 1.4 billion people, and a proportion of that population is deployed in doing technology. US has 300 plus million people, and a proportion of that is being deployed in technology. So if in China, the per capita income is $10,000, roughly 10,839, and US per capita income is $65,000. So it is very natural that the output of the Chinese companies is going to be much more competitive in the world. Give you an example. As the Chinese players are taking dominance in the hardware, for example, they are now 60-70% of the hardware, which means mobile phones are sold in the world are Chinese mobile phones. And they now have every single application, whatever US has, they have every single application built there. AI, they're investing heavily. So which means that they have potential to dominate. So let's say against a YouTube, they have a Youku, and there is a potential, because the cost is low. They can tell to the user that, okay, if you watch the content on Youku, the same content, you're going to get some money. So those kind of conflicts are going to happen, and therefore there is no doubt that the Chinese companies versus US companies, and not only US companies actually. The issue is, because China is so large, they are not only targeting to go at the top level, they are also threatening Japan, they are also threatening Europe, they are also threatening, Korea and Taiwan, because they have memory, they have, chipset, etc. And they're also threatening even the lower level of countries, because they have large population, despite that they are growing in per capita income, but they don't want to, let their low-end jobs go. So therefore, in a nutshell, it's almost like China versus the rest of the world. So let's see, so this is one important aspect, that geopolitics help precede business, and therefore, one need to understand that we have allies in the rest of the world, and that's an opportunity of India and Indian companies and Indian people. And the second, it is also an opportunity that how China has risen. This is how from 1960, this is how India has done in per capita income. We are by 2020, we are, when we started after independence, we were 3.9% of global GDP. Today, it is a pathetic situation. We are just 3.2% of the global GDP. Actually, we have not grown. We have degrown. So each one of us has not done a justice with the country. Each one of us who is a leader has actually failed, miserably failed. Anyway, we are just 1877%, $1877 per capita income. And this is how China has grown. You see the exponential curve, the hockey stick curve. But that also brings issues for China, because the low-end manufacturing, China has no option unless they subsidize very heavily. They have to let it go. So these two things are tremendously in India's favor, and therefore it's an opportunity of India. Now, what I have done, I have actually done a deep research work that what happened, why China grew, and why we stagnated. It is not because of any issues which India has. It is just the issue of the leaders, each one of us, as I've told you, that we failed together, from politicians to the bureaucrats to the industrialists to professionals at the higher level to, I would say, the media people and the judiciary. The six forces combined, we have failed the nation together. So now, but I will not go into the details, because we'll keep that for rest, because I know exactly every single nation who has prospered has done just similar things to prosper, but that's not the perspective today. I'm not going to share that. I will bring from this to our industry, because that's what you people are here for, that how the industry is shaped up today. So the competitive advantage has actually led to the consolidation in our industry. If you see at the top, we have Apple, Samsung, and Huawei, and each company has a solid differentiation. Apple in the software, hardware, and iTunes. Samsung, they are the only company in the world to control the supply chain end to end. They manufacture chipset, memory, LCD, display, battery, connectors, cameras, camera module, sensor, and whatnot. So they are the only companies with end-to-end supply chain. No one else has that in the world. And Huawei, the way they are leading in technology, 5G, they are quite leading actually, and 6G also they are working very heavily and investing a lot of money in R&D, much higher money than anyone else in the world in investing in our industry. And therefore, they have certain differentiation there. Then in the mid size, which is the middle market. So if you can look at the auto industry, I'll call these top three companies as a Merck, BMW, and Audis, and these are the Toyotas and and I would say Hondas of the world. So what they have done, that they have created excellence through focus. They don't do any other business, just the mobile phone business. And there are four brands, a BBK group: Oppo, Vivo, OnePlus, and Realme now. So and second is what they have, which no one else has, is the partners' trust. Their partners came to India and they're going to the rest of the world. They don't have any sales company. They have their distributors. And they trust so much that the distributor lost roughly about $1 billion before started making money. No company in the world can boast that. And therefore, that's their differentiation. And similarly, at the bottom level, Xiaomi came up with a business model, which was efficient business model, which was followed by Honor and Realme. And that is the differentiation they came up with. But this business model actually is a short-term thing eventually. It can be beaten. Therefore, you can see the Honor and Realme are here. So because of that, they have created. So world is tagged now in 5 companies and this 6, 7, 8 brands. And there is an ecosystem which is supplying to these 5 companies. And this ecosystem is very happy in supplying to these companies because they don't have any motivation to make anyone else successful. So it doesn't matter to them whether a Nokia or a Lava or a Motorola or any other company exists or not, because 95% of the value comes from this. So what are we doing today because of the opportunities that I shared with you, is that we are creating an alternate ecosystem in India, because that's the opportunity of India. We are creating that on the 2 pillars. One is the pillars of India, and second is the pillar of the partners. On India, we, in this context, if you see the advantage of India, we are, a large human capital eagerly waiting to be deployed. I call them PhDs, the poor, hungry, and people. And then we have, even in the IT, we have done a lot of work in the last 30 years. Not, I would say, work in the product, but mostly services. But still, we have a large pool of IT in electronics. This is the critical one. Then we have a 20% of the world market in terms of at least volume market. Roughly 18% of people live in the country, and in a particular segment, we have 20% of the world market in the lower end segment. And as we started moving the production to India, we actually our productivity was more than in China, and our costs also 1/3 in manufacturing and design. I've shown you from the previous charts that as we are going to acquire skill, no one in the world can be more competitive than us. So this is a great opportunity for India now in this. And with this thought process, we went to the Prime Minister and we've taken the Prime Minister announced that in 2018 end that India will become the #1 hub for mobile phone manufacturing and design. And this policy was built with a robust architecture. It was never thought to be built on just local market, because what we think about our market is very large, but our value market is nothing, because we are just 3.2% of the global GDP. Our value market cannot be more than 4.5% of the global GDP, because even if mobile is so close, but our value market is only 4.5%. So therefore, the entire focus of ours is now to take our share from the 96.8% of the world. And that's the only way we can employ our 18% of the population in the jobs. So the entire focus sports. And the second thing I would say, and this is going to be done by two sort of forces. One is global champions. And for the first time in the history of independence, that the government has realized that the only way to build the country is through its domestic companies. And then they are talking about domestic champions. And therefore, for the first time, so to do there's a target actually to create this ecosystem. There's a target which we have kept under policy. In 2019, we have produced about 339 million mobiles, valuing about $25 billion. In 2025, the target is to produce 1 billion mobile, valuing $190 billion. And exports, we've done just 16 million phones exported, worth about $2.3 billion. And the target is to export 600 million mobiles, valuing $110 billion. Our domestic market is also going to grow to about 80 billion by 2025. So that's the target we have. There's a very large, and when we'll do this, we'll become almost number one in the world in production of mobile and also the mobile design. So for that, a PLI scheme has been announced, and this is the differentiation I said, that above $200, the global champions are going to get this scheme, which you must be aware of. So I'm not going to go into the details of the scheme. And that's what I was telling. The first time Indian champions to build the skills, there's a differentiation, because what we believe that Indian companies will lead it in this segment, less than $200 segment. So Indian companies will get this PLI at any value, but which means less than $200 segment is completely left for Indians, and the scheme is only for Indian companies in the less than $200 segment. So this is about India and what India is doing in terms of government and what India is tagged. And then there's the partners which I shared with you about. That Indian champions, with the partnerships of large companies like Google, Qualcomm, and many other, Samsung, many companies are sincerely looking at India and Indian companies to help them to create a balance in the world. And it's not just in the mobile phones, it's in every single component, every single part. There's an opportunity wherein, because everybody wants that there has to be a second source of procurement of not the mobile phones, second source of procurement of parts and components. Therefore, a China plus one strategy is very, very critical. And most of the global champions are looking at helping to build the Indian ecosystem. And the countries, the partner countries, we have seen very deeply how Apple is coming in and building their ecosystem. Qualcomm, Google, all these companies are, very sincerely looking at helping this Indian ecosystem. Similarly, Europe is also, through other technological means, because they have certain machineries which they are not giving to China at the moment, in terms of, let's say, the chip making machineries. And of course, Japan, Korea, Taiwan, all these three companies are threatened by China's next move, and therefore it's a great opportunity to partner with these countries and the companies of these countries. What has happened? Shifting ecosystems of manufacturing and carefully crafted government policies have led to national champions. And what happens? National champions means what? I looked at 500 companies, what they produce. 500 companies of the world, the top 500 companies of the world, they produce $30 trillion and their ecosystem put together. they produce $30 trillion, just 500 companies, which is 38% of the global GDP. Of these 500 companies, 9 are in Taiwan. They produce 66% of Taiwanese GDP. Of these, 16 are in Korea. They produce 50% of Korean GDP. Similarly, 28 are in Germany. 28 are in France. 50% of French GDP. 32 are in Germany. 50% of German GDP. 111 companies are in China, contributing to 50% of Chinese GDP. So how the countries have built, and 128 companies are in US, contributing to 43% of a $20 trillion GDP, which means about $8-9 trillion, 3 times of what altogether the country we produce. Just 128 companies of US produces, 3 times of that. So what has happened after the world became atomic bombing happened in the Second World War. No more conventional military was required. So countries build their companies to actually take their share from the global world. That was the only methodology adopted by the economists. We were probably not aware. But those countries whose leaders were completely clear that building national champions is the most important thing, I think that those countries worked and they have been able to create great companies. So if you see this from 1840 to 2025, this graph, so you see when the Europe was developing the Siemens, this is exactly as per the timeline. If you see, Siemens was roughly about 1850, 60 companies, 1845, something like that. Then Nokia, 1865. So this is Nokia, Ericsson, Benz, Philips. This is the European ecosystem. Then Ford, IBM, Motorola, the US ecosystem after the 1900. Then Japan, Toyota, Sony, Honda after 1940. Then Korea, LG, Samsung, all electronics company after 1960, when the ecosystem started moving to Korea. Then Taiwan, Foxconn, Acer, Asus, all these companies in the 75s, in the 70s and 80s. Then China, the Lenovo, Huawei, the BBK group, all this is this time. I think this is time that there is going to be an exchange. And this is the time for us to make Indian champions from India. The stage is set, the opportunity is there. We can create national champions, not only in the mobile phones, but in every single component which is being produced, in the design, in R&D. You will be surprised to know that the number one company in the whole world is not Apple, is not Huawei, is not or a BBK or whatever. The number one company in the whole world is a design house in terms of volumes, I'm saying, of China. One design house of China. 3 design houses of China caters to about 50% of the global market in mobile phones. And one design house of the China is catering to about 25% of the global market, and therefore they are number one in the smartphone industry. So it is an opportunity for India to look at R&D and design and create value in designing not only the whole phone, but also the chips, and do ATMP process. And we are looking at, going into this journey, but it's going to take a lot of time for me to explain, but I'm going to explain that. And government is looking at creating R&D fund. Government is looking at, so we are working with government to create a center for excellence in R&D, in mobile design. And there's an opportunity to create center for excellence in chip designing with government support. ISA has to work and do that. So that's the opportunity we have. And what we are looking at, what is the vision and target for Indian champions in this industry and the ecosystem? This is what we see. That what we can do, anything valuable, we can make it accessible right now. We are at that stage of our journey. And as we are going to be the most competitive. And therefore, number one in the $200 segment of this ecosystem. What is the market size here? If you see, more than $600 segment has 168 million units. It's a $480 billion market, $450 to $470 billion market. 168 million units are sold in 600, more than 600. 468 million units are sold in between $200 and $600. And this is the market. About 1.3 billion units are being sold in this segment, less than $200 market. This market, once we are going to acquire skill with 1,800 X dollar per capita income, no one in the world can compete with the Indian companies. And therefore, in volume terms, Indian companies can become the largest in the world. And whether it is a design in the mobile phones or it is the other ecosystem, that's an opportunity what we have. So put together from parts to mobile phones and design put together, we believe that this opportunity put together is going to be 500 billion. And if we are going to take a 50% market share, this is a $250 billion opportunity by 2030. That's the opportunity we are sitting at. And so therefore, what I was telling you, it is the most opportune moment in the history for our companies to get up and take this opportunity, grab this opportunity. But it's very important to remember that we can't be a small company. A small companies are going to go actually, and therefore it is very important to first dream big. Are you going to be number one, number two, worst case number three in particular segment? Then only you can actually create value. Anyone can create value. Second thing is to understand that government support is a must because it's a time for India and Indian companies to acquire skills. And no country has ever been able to do it, from Europe to US to Japan to Korea to Taiwan to China without the government support. First the government evolved, then the company started evolving. In fact, IT industry is the only industry, happened without the government support because it was just the human to human competition. It was never an ecosystem competition. So therefore, government support is a must for building an international level companies. And therefore, and I can only tell you, when I used to be on this side, I've never taken support of the government before 2018. But what I realized is that government is also very eager to understand because frankly, they are looking for exposure. And once we are there, letting them know the right things, anything is possible. If something is not happening, it is our problem. It is not government's problem. It is the opportunity, it is the responsibility of the industry to ensure that government does the right thing. And to do that, we have to deserve it. We have to understand that we are the lid. If we are going to deserve the government support, we are going to get the government support. Thank you very much.
Hello, good morning, good afternoon, good evening, everyone. Hope you are all staying safe and healthy. I'm Sambit Sahu. I lead the IoT engineering group in Intel. I and my team, we deliver lots of products in AI, ML, computer vision, edge computing, and few other segments. In the next 30 minutes, I'm just going to give you an idea about AI and how silicon is playing a very critical role in the development of AI. Just want to share with you the legal disclaimer from Intel. Moving on, AI is touching us in every aspect of our lives. If you look at healthcare, lots of AI applications or development is happening on medical imaging, drug discovery, and vaccine research. If you look at education, AI is playing a pretty big role in online education and providing an immersive experience to our students. In smart home, a lot of devices, intelligent devices are getting connected to build a smart home. And then the smart home can build a smart society, and then smart society can go on and help build a smart city. Lots of AI stuff happening in agriculture on intelligent harvesting, or intelligent pest control systems. So AI is touching in every aspect of our life. And next 30 years, these AI applications is going to be very impactful, very explosive. And with the advent of 5G, the experiences and the performance is going to become very significant. I just want to share with you a research done by ABI Research. By 2035, the economy value from AI and 5G is going to be around $17 trillion. $17 trillion. And 2025 will be an inflection year, because by 2025, many of the foundational technologies would have been established for AI and 5G. And we expect this AI 5G combination to start going on explosive growth from 2025 onwards. Just to give you another perspective, the silicon for AI in both cloud and edge, both training and inference, is expected to be around 18 billion by 2024. So as you can see, lots of development, lots of action happening worldwide. Now, this whole AI thing, so many companies are innovating, so many companies are developing. I would put them into three categories. One is the AI application categories, where a lot of AI application developers are building new applications every day, whether it is smart home, or it is transportation, or smart agriculture. The developers are really building these new applications every day. The second big piece is the software infrastructure, whether it's the compilers, the operating systems, the profilers, the algorithms. That what I consider the middle stack. And the third stack, but not the least stack, is the silicon that is going to process all these applications, all the software. My focus of this presentation is going to be on the silicon. All AI, machine learning, deep learning, it takes its foundation from the human brain. A human brain, which is intelligent as we all know, has lots of neurons and lots of interconnections or synapses that connect these neurons. Similarly, a AI or a machine learning computation engine needs lots of neurons and lots of interconnections. And this whole computation and this whole neural network processing is based on the foundation of very strong mathematical and statistical algorithms. Just to give you an idea of the complexity of human brain, there are around 200 billion neurons, 32 trillion interconnections, all operating and making the human intelligent, using a very small 20-watt power. So you can imagine what kind of challenge we have ahead of us. To give you one click down, how does a simple neural network look like? It's a multi-layer configuration. It has an input layer, multiple hidden layers, and an output layer. And each layer, there are hundreds of neurons, each neuron doing some processing, and each neuron transmitting some information to the adjacent neuron. And there are lots of these hidden layers, maybe hundreds of hidden layers. And as I said, each layer has hundreds of neurons, and each doing some amount of complex computation and passing the information to the adjacent neuron. Now, this is a simple neural network. There are lots of new types of neural networks that are evolving, like recurrent neural networks, convolutional neural networks, partial neural networks with memory cells. So lots of different types of neural networks evolving. So the silicon providers have to consider all this while designing their silicon. Now, When we are designing silicon, there are different attributes or considerations we have to take while designing silicon. One is, as you saw from the diagram, it's about lot of massive and parallel computation, which can be enabled with techniques like SIMD, which stands for single instruction, multiple data. There are lots of memory necessary to store the partial computation, to store the weights, to store the biases, lots of memory. And this memory needs to be fast. The memory access time needs to be fast. So those things also have to be considered. Accuracy. We have different trade-offs between accuracy, performance, and power. Like training needs much more accuracy than inferencing. So while designing a neural network silicon, we have to look at trade-offs between accuracy, performance, power. Energy efficiency. Doing so much computation, having so much of memory, it takes a lot of power. We have to really look at it, how to make things very energy efficient. Particularly, if you have to bring these neural network engines to our wearables, to our handheld devices, to battery operated devices, power efficiency, thermal efficiency is going to be very important. Performance, very critical. If you have to do lots of training, you have to do lots of process, lots of data, very accurate, we have to make sure that performance is key. Performance in terms of tops per watt, tops per millimeter square, all these are metrics for measuring performance. And also for real-time application, for example, in driverless cars, quick response, quick processing of the environment, quick reaction are critical. Cost, as we all know, silicon is expensive. So we have to make sure while we are designing silicon, that cost is very carefully considered. Adaptability. As I said, the neural network applications or AI applications evolving every day. The types of neural networks is evolving every day. We have so many different types of neural networks coming up. Our silicon has to make sure that we cater, we adapt to the different type of applications and to the different type of neural networks. Scalability is another big thing. We can't put so much processing in one single die. We have to put multiple of these dies or multiple of these silicons. So you have to make sure when you design silicon that they're scalable. We should be easily put multiple of the silicon together without having any significant loss in performance. Okay. So these are all the key attributes we have to consider while designing silicon. Now, many companies are working, towards silicon development for AI and machine learning. They are evolving their assets, they are evolving their technologies in order to adapt to these challenging needs and these growing needs of machine learning. For example, Intel is banking on its Xeon CPU assets, multiple cores, multiple sockets, spatial neural networking processing instructions, spatial neural network processing hardware. And Intel Xeon has an advantage that has a huge user or application base. Now, NVIDIA is leveraging its very powerful parallel computation that have been traditionally used in graphics. And is also leveraging or co-optimizing the silicon with its CUDA ecosystem. FPGA companies like Xilinx, Altera, they're also looking at how to make an impact in this space. The advantage of FPGAs is that they're reconfigurable, we can quickly prototype, They also have some special DSP functions that you can leverage upon. Then there are companies like Google, which are doing their very specific ASICs to get the best power performance advantage for their applications. So Google has designed Tensor Core for this, and you can put multiple of these Tensor cores to form a Tensor pod. And then accelerators. I mean, we are working in Intel, my team is working on computer imaging and video inferencing accelerators by taking a combination of computer imaging and neural networks. Okay. So as you can see, different companies are using their assets, existing assets, or evolving their existing assets to go on this journey of AI and ML. And so far, most of the neural network that has been developed are largely synchronous in design. Okay, pretty much the processing happens in every clock cycle, but that's not how the human brain operates. The human brain is asynchronous in nature. The human brain is event-driven. So there are some advances happening, which we call as neuromorphic, where the silicon is being attempted to closely match the human brain. So Intel developed a research chip called Loihi, which is a neuromorphic chip, which is based on these fundamentals, that is to match the human brain, that is asynchronous in nature. It is event-driven, and it uses a technology called LIF, leaky integrated fire. So this chip has been taped out and is being now evaluated. It has 128 cores, and with each core has around 1024 neurons. So that gives us around 128K neurons and 128 million synapses or interconnections. And all these cores are interconnected through a 2D mesh. So this is again in a very research stage. We see some good promise from the results we have seen so far. And just to share with you some of the results, what we see for some of the applications, this neuromorphic chip, which closely matches the brain, is around 1000x faster than the traditional CPU, around 10,000x more power efficient because of its asynchronicity and event-driven nature versus the traditional CPUs. And also is scalable. We can put multiple of these neuromorphic chips together to achieve a very high number of neurons and high number of interconnections. As I shared with you, a brain has 20 billion neurons and 32 trillion interconnections. So by putting many of these together, we are making an attempt how to closely match the human brain. Other design considerations, as I shared, memory is very critical. We need to make sure that we have enough memory capacity to store the partial computation, to store the weights and biases. And also memory latency, memory access time, memory power. All these are going to play a big role in the goodness of our neural network chips. So lots of research happening in the memory, looking at high performance memories like DDR5 and onwards, HBM memories. How do we stack memory so that we can get the latency advantage? Memory coming close to compute so that we reduce the latency and make the power better. Even some research happening, really, how do we introduce some amount of computation memory so that we don't have this memory and compute like two separate entities, but put some compute in memory to do the processing. And there's another research going on called analog memory registers, really, to how do we store these weights or biases, as analog memory registers are not like our traditional memories. Okay. So lots of development happening in memories. And as I shared, to mimic a human brain, we need to put multiple of these silicon, multiple of these dies together. So lots of research happening in putting these multiple dies together, whether MCP, multi-chip in a package, or a 3D stacking technology, or a wafer level processing. There is a company called Cerebras. It uses a one full wafer as a single chip, very novel technologies, and is able to pack around 2 trillion transistors into the chip, one chip from a wafer. And to put these multiple dies together, we also need very fast die-to-die communication. So lots of advances going on in this die-to-die communication, like CXL links, InfiniBand, OmniBand, and RDMA, where you can transfer with very fast, with very quickly, with low latency, the content of memory of one processor to another. So lots of developments happening in this die-to-die communication. Apart from this, we're also integrating a lot of IPs to enhance the capability or the efficiency or the applicability of neural networks. IPs for real time, IPs for computer imaging. Some of these IPs are getting integrated into chips with neural networks so that we maximize the applicability of these neural networks. Just to give an idea, there are three types of silicon providers. One of the semiconductor providers who sell the chips to the broader market, like Intel, NVIDIA, Qualcomm. The second category I would say are the IP providers, which provide some IPs for the companies which build silicon. IP providers like ARM, Cadence, Synopsys, they are developing IPs to enhance this AI and ML journey. And the third category I would say is captive vendors like Apple and Google, who develop their own ASICs and use it in their own products. You may have seen Apple iPhone 12. It has a neural network engine embedded in the iPhone 12. So these are examples of how some of these captive vendors are developing their own custom ASICs. Okay. So many companies investing significantly. They're doing lots of things to advance, and this is going to continue for next few years. I just want to now share really how Intel India is making an impact to overall India AI growth. Lots of work happening in understanding, the India traffic system. Then how do we create safe conditions for our drivers, for our cars? How do we enhance the healthcare in India? So Intel India is playing a significant role in both its hardware and software assets in expanding India's aspiration AI. And I believe this whole AI neural network will be a big player in India's aspirations to be a $1 trillion economy. And also Intel India is developing a lot of curriculum courses, partnering with the government and education systems in providing good courses, good agenda to our students in schools and universities. So lots of activities happening, and I'm really glad that Intel India is playing a significant role in enhancing the AI strategy of India. Also, we developed an initiative, INAI, Intel India, in collaboration with the government of Telangana and Ministry of Technology. How do we use AI technologies, AI infrastructure to grow the India economy to make our people life better, because ours is a country of a lot of population, how we scale our AI technology to the population, and also how do we protect people's privacy and security. That is going to be very important. Okay. So Intel India is partnering with the government, particularly in the areas of healthcare and smart mobility. Now, as I said, I would say we are in the brink of a revolution. Next few years, there are going to be lots of technology advancements. There are going to be a lot of developments. I've just outlined few areas here. One area is really how do we develop silicon for customized silicon for different type of workloads. Workloads like video, audio, multimodal, text, real time. We may need different type of silicon for different type of workloads. Second is, as you saw, we need a lot of computation power, but we need to see really how do we deliver this huge computation in a very power and cost efficient manner. The third is really how does the silicon adapt to new neural network models that are evolving every day. The fourth, the silicon and software have to really go hand in hand to give the best experience, to give the best performance. So how does the silicon and software, they co-optimize? Quantum computing, it's a little far out research, but if it succeeds, is going to play a big role, because quantum computing, it could eliminate the challenges of today's computing of lots of computation power at very low, lots of computation at a very low power, or solving a lot of unsolvable algorithms. So quantum computing could play a key role, but I would say it's in a research stage right now. Neuromorphic, as I shared with you, Intel's Lohi chip, and it's still a research topic, though there are early promises. And I expect neuromorphic is going to continue to advance, because for us to succeed, our neural engines have to closely mimic the brain. And then I see lots of new applications, new requirements coming up, which will need neural network, like robotics, natural language processing, even driverless cars. Lots of technology and lots of new silicon stuff could be necessary in these areas. Okay, so lots to do. I will expect next 10 years we'll all be busy in advancing these technologies to get the best out of AI, and very importantly to fulfill that $17 trillion economy predicted by ABI research. So lots of opportunities ahead of us, lots of challenges ahead of us. Okay. So with that, I will conclude my talk. I just want to acknowledge and few references which I picked up for this discussion. You can find them on the web, in IEEE sites. I would like to thank all the publications and papers that I picked this talk from. Thank you all.
The session started with two very important keynote addresses, one by Mr. Hariom Roy of Lava International. He gave a very broad picture about how India can become competitive in mobile phone and basically other electronics product. And then we heard from Samit Sahu the importance of artificial intelligence and how silicon is playing a major role in the development of the artificial intelligence, right? We have put up this panel with basically eminent experts, as you heard the intro. The main theme of this session is to basically discuss how a category of products which are of national importance can be basically designed and manufactured in India with basically all the way from basically chips to systems, right? So both components and the system level. Couple of the products basically which are on the horizon are utility meters, for example, smart meters, very large market. It's estimated in the next 5 years or 7 years, there will be 250 million smart meters will be needed. Things like set-top boxes or converged media gateway, things like fiber to the home devices and wireless routers, things like obviously everybody talks about 5G base stations and so on and so forth. And also basically domestic supporting ecosystem where basically Indian manufacturing companies either in the component or the system space can help in manufacturing these companies, right? So that's going to be the focus of today's discussion. So I'll start with Ajay Chaudhary sir. You have been basically involved in the this type of the initiatives in the past 15 to 20 years. How do you see the opportunity of developing these products end to end from basically chips to system in the current scenario, and what can we do about it?
Well, actually, there is a very large opportunity for looking at volume products to be made in India, really from chip to system. And I think this opportunity is become not just an opportunity, but a necessity. And the necessity is happening because there is a new geopolitical situation that we are facing. And due to this new geopolitical situation, security becomes a very important part. So keeping security in mind, I think if we look at products that you sort of mentioned, like media gateway equipment, Wi-Fi routers, CCTV cameras, smart meters, products like these are essential if we want to look at reducing imports and creating an Atmanirbhar Bharat. And in addition to that, if we look at this whole issue of COVID, it has also highlighted the fact that we have a serious problem of digital divide. So keeping digital divide in mind, I think we need to create products that can be actually used for distance learning, and therefore a very low cost product like a tablet would be a great need for the country if we want to take distance training, distance learning, distance skill development as we go forward.
Thank you, Ajay. So Sanjay, next question is to you. As probably Tejas is one of the most prominent electronic system domestic companies which have come out in last 10 to 15 years, right? Obviously HCL was pioneer, but in last 10 to 15 years, you are the poster child of the electronic systems company in India. So how do you view basically developing more such products from the domestic company, and from your experience, what is the right way to do it so that basically we achieve a reasonable success in this endeavor?
Thanks, Satya. First of all, pleasure to be on this panel and sharing ideas with Ajay in particular. We have been working on this ESG mission for the last 10, 15 years. So two things which you asked, let me talk about the first one, that what do I think of the opportunity? And then second question is, how do we do it? So in terms of opportunity, let me give you two very simple ways in which a country like India needs to look at the opportunity. Let me start off with the telecom products, which are really very critical for national security today. For example, just imagine we are having this face-off in Ladakh and Doklam and all that stuff, if the communication system that the Indian Army is using happens to be designed and owned by a Chinese company, there goes all your Air Force and Navy and all the people on the ground. So I think communication infrastructure is as important an asset today for the country's national security, economic security, and social security than ever before, especially because everybody in the country, especially post-COVID, is using some kind of telecom infrastructure. Just to put some numbers onto ground, we are talking of, if you take a 4G full-fledged system, fiber to the home infrastructure and the 5G ecosystem, we are talking of anywhere between $100 to $200 billion worth of capex investment that India will need to import if we don't do anything. So this is the cost of not doing anything, is at least $200 billion over the next 5 years. And I'm being conservative here. People are talking much higher numbers for 5G. Number two, the business potential of, if we do it, because it will create jobs, it will create the entire ecosystem that we've all been dreaming to create, is also enormous. Because if I just take a very simple project like BharatNet, which got created, which is rural connectivity, at this point in time, 120 countries in the world are essentially doing their equivalent of BharatNet, including countries like USA, UK, which again have very poor rural connectivity. The total budget in the world for just rural connectivity project is close to $500 billion. So if India can get the success that we have created out of BharatNet and replicate that infrastructure outside of India, not just the telecom equipment, but the Aadhaar, the UPI, the software stack, we are talking of a few $100 billion of export opportunity. So just for these two reasons, I think economically it makes sense. The third reason I would say why it makes sense and how do we do it, which will lead to my next point, is India is possibly, we have a lot of self-doubt. Can India create its own ecosystem, etc., etc.? So let me share a few data. Other than China, 50% of the telecom systems or R&D engineers working in telecom systems in the world are possibly in India. And other than China, 50% of chip designers of the world are actually working in India. So I think with this amount of talent, with this amount of capabilities, it's actually unfortunate, and it will be a irony of sorts if India doesn't do anything about it. Now coming back to how do we make it all happen, because it's very clear that we need to make it. There is no choice. There are really 3 or 4 things I would say are very easy to do. The good news is the ball is already moving by the government. So there are a few fundamental policies which are in place. Number one, I would say the preference to make in India policy is a very powerful policy. It's a very fair policy. It is economically, viable for the government. They don't even have to pay $1 extra, except it gives an opportunity, a business opportunity to leverage a large domestic demand to create domestic products, because you can create products in isolation, but if you don't give them market, I think those products will become obsolete. So the Make in India policy is a very good policy. However, it needs to be implemented better. Today, what happens is the policy is there, but unreasonable technical specifications will be made so that Indian companies are not able to bid. So you create I'm just giving you one simple example. In a small state in India came out with a tender, and the number of IP addresses that they wanted the equipment to handle was 2 times the IP addresses if every person in the world. So it was 2 times the population of the world which they needed as an IP address, just because they wanted to specify something which a foreign guy wanted to do. So I'm just saying we should avoid the temptation of unreasonable specification and make the Make in India policy fair. So that's point one. The second one, which I would say is a very important policy, which has just been launched a few weeks back, is the PLI policy, the Performance Linked Incentive. I think why I'm insisting on the policies which exist, because these policies still are at the framework stage and we can actually make them happen. So if the PLI policy is made to give R&D benefits, manpower benefits, and support for the ecosystem, we can really make that happen. So that's really where I would stop for now. So in fact, so maybe then I will, so basically I just wanted to summarize saying that the PMI policy needs to be implemented tightly. The PLI policy needs to be done so that we create the pull for chips, the systems and the ecosystem using our domestic demand. And both these policies, I think government needs to really take the industry on board and make sure that the inputs are really done to encourage value addition and local, capability creation. Maybe since Satya is not there, I would pass on to Amrit Manwani ji for your opening remarks, and I hope Satya will join by then.
Thank you, Rajiv, and it was nice to hear from you and Ajay ji about what your thoughts are. I represent the component sector, and for last 30 years or so, this sector, the electronic component sector, has actually been very highly neglected, if I would say so. And mostly because of the ITA one regime, all the components were in a zero duty regime, and therefore there was no incentive for the components to be manufactured in India, and therefore we kind of lost out to the world in terms of the building block, which is the components, the manufacturing of components almost disappeared from the country. However, recently the government seems to have realized the importance of electronic components. And they have, as Sanjay ji rightly said, they have come out with a PLI scheme in October. Of course, the components were tagged along with mobile phone manufacturing, but at least the government realized that without the component ecosystem being in place, the electronic production would not, increase to the level that is desirable. And therefore, that's a good step taken by the government. I would like to focus a little bit more on, one of the segments that is very important for the country, and that is the memories. And why I'm focusing on the memories is because as Mr. Sanjay Nayak earlier said, we are completely, as of today, dependent on our component requirement for the memories to the nations which are in our neighborhood, and they create a lot of challenges for us. To quickly, run you through, what we are talking about, the total demand for memory products, the semiconductors, what we talk about, NAND memories or NOR memories, is typically about $130 billion worldwide. And this is predominantly the domain of countries like the US, Japan, Korea, Taiwan, and now, of course, very aggressively China. And therefore, unless we position ourselves in this space, we are going to have big challenges in terms of our own security requirements, particularly in the data storage domain, and also in laptops, notebooks, other storage devices like servers, which are for data storage. In India today, there is, going further down, we all know that there is no fab in the country. And, people do question about, if we set up a fab, would it be viable, or, what, it'll require a lot of investment, which currently the country perhaps cannot afford. But, one thing is certain, that whether it is appropriate now or no, that is a debatable point. But as we go along, the fab has to come to the country. Otherwise, we will be left out. But before we go into the fab, we should really look at downstream in the packaging industry. As of today, there is really virtually no packaging company in the country, barring a few discrete semiconductors are packaged in the country. Worldwide, there is a $30 billion industry just for packaging. And I'm talking of memory packaging. In India, we have none. And this is an area which is very, very important to get into. And there is a scope for at least, several players, at least 10 or more players who could get into this space. Just to give you an idea, last year, there were about 9,000 crores worth of memory products that were imported. And there is, again, as I said, there is no manufacturing in the country or packaging industry in the country who does just the packaging of the semiconductors. So I would stop here, saying that we should look into the packaging industry seriously. Of course, government through PLI scheme has has given incentives to the packaging industry, and that is a very welcome policy decision that the government has made. So I would hand it back to Satya if he's come back. I briefly saw him come online, but if not, I think Steve is here. He can take over.
Yeah, so Amrit sir, thank you so much for your basically comments about it. So Sanjay, you talked about BharatNet, right? What are the learnings from here? Because it took very long time to basically implement the concept, and basically there were a lot of initial 5 to 10 years. The deployment was very less. Then it picked up in last 5 years, right? So uh, if you have to run these kind of the infrastructure projects to enable the rest of the products which we are talking about, right? What are the learnings? Why it did not happen for first 8 to 10 years? Earlier it was known as NFN, and then it became BharatNet and so on and so forth, right? So there must be some learnings from basically since you have been involved and companies like UTL and all those people were involved as well, right? What basically worked and what did not work?
So first of all, just to put the timeline into correction, I think around 2014 is when NOFN was conceptualized. And just to put a scale issue, there are a lot of learning, by the way, in terms of project management, the way the structuring was set up between BBNL and BSNL and the other utility companies. I think maybe a slightly different structure would have worked better. But just to put things in perspective, on the positive side, BharatNet is the world's largest rural broadband greenfield project by far. And just to put you another angle onto it, the per subscriber cost of giving data services on BharatNet is $20 per subscriber, compared to $500 for a per subscriber in US and $1,100 for a per subscriber for the NBA in Australia. So I would say that it took longer than what it should have taken. But the point which I think what you are alluding to, Satya, is that if you are going to create an Indian ecosystem around projects which are of large scale and national importance, how do we ensure that the ecosystem alignment with respect to the project timeline syncs up? That's really what your question is. So I would say the way to think of it, that the technology definition of the components that are required is important. Let me give you two specific examples, which can also become a good talking point for the rest of the panel as well. Number one, let's say India today has less than 5 million home broadband subscribers. And it is expected that in the next 3 to 5 years, we will have anywhere between 200 to 500 million home broadband subscribers, say 200 million home broadband subscribers. So 200 million home broadband subscriber at an average cost of about $40 or $30 per subscriber, you're talking of a $10 billion opportunity here in terms of a systems opportunity. And this is for a very simple technology like GPON. So if we can create the ecosystem in India, starting from the ONTs, which is a modem, which has Wi-Fi, like Ajay mentioned earlier, integrated into it is the home creator device. If every home can have, instead of a cable set-top box or a modem, one box which has a Wi-Fi, which is a GPON interface, you're good for 100 gig, 200 gig, terabit, I mean, for good forever, right? Then you're talking about 10 billion opportunity. Now, 10 billion opportunity, if you break it down to the system content, you're talking about 30 to 40% of that in silicon. So you're talking of a $4 billion semiconductor opportunity, which I think Indian fabless semiconductor companies in the period of less than 12 months can create the chip that goes into the ONT, which is a very simple chip. The chip that goes into OLT, you just focus on two chips, and here you got a $4 billion chip opportunity knocking at our door. Given the complexity of technology, this can all be implemented in FPGA on day one, and then move from FPGA to a hard silicon within a period of 18 months once you got this done. So here I'm talking of one concrete project, and the fact is, our Prime Minister has announced that currently BharatNet is only 125,000 villages. For the next 1,000 days, we are going to go to 6 lakh villages. On top of that, if you go to Mukesh Ambani's announcement that Jio wants to have 100 million home broadband subscribers, we are talking of a single opportunity of a 10 billion kind, is tractable, doable, should be done, and can be creating the ecosystem. So this is what I would say would be one example where you develop the chips, develop the home broadband modem, develop the head-end devices, create a market access pull in the form of PMA, which is already there, create a PLI, because PLI will give you the handicap which you can, kind of get past, so that if you're going to get a 10% subsidy for R&D for your chip design or for system design or system guys who use the chips, suddenly all of the 10 billion can be kept within the country. Versus the cost of doing nothing is, in the next 2 years, we will write a check of $10 billion for our neighbors, and while thinking that we could have already done this in the country.
So hopefully we can do better than 10% subsidy. I think you should hear some good news in next 3 months around that. So Ajay sir, taking the same example, right? If we go to the education segment, which is very passionate subject for you, right? Creating a basically affordable tablet for millions of people. BharatNet probably can provide them the connectivity and the tablet can basically provide them the media to access, right? So we have tried this before. Okay. If you remember, basically about 7 years back, similar to BharatNet, we started a program called Akash, right? Where basically the plan was similar to create a less than 5,000 rupees tablet, right? So what way we can do different to make it basically a successful recipe, again, going from the, just like Sanjay said, chip to systems in the ONT devices. What we can do for the education type of the tablet, because that is not just commercial. I think this is a social responsibility also for all of us to make sure the education reaches to the masses in broader areas, not just rural, but second tier, third tier cities as well. So what you say that what is the success recipe so that we don't basically do the mistakes which were made in Akash days?
It's not just a situation of rural, it's all over the country.
Yes.
Just last week, a girl from LSR in Delhi committed suicide because she could not get hold of a tablet. So it's such a sad state of affairs. This digital divide is not there, is there all over the country. Now, if we look at this whole Akash experiment, Akash was very good as a strategy, but very poor implementation. Strategy-wise, what did it do to the country? It dramatically reduced the price of tablets in this country. And this happened with the MIT product also many years ago, when they came up with a thin client or a small product which they were talking about, which was one laptop per person, that kind of a concept. So, as a concept, there was nothing wrong, but the implementation was really poor. You can't just hand it over to a education institution and expect the product to be developed. I think you need to involve research, education, and industry all together. And if we actually do that, then we can be successful in creating such products. And we must look at what is feasible and what is not feasible. So we need to look at that very early days. And if we can create this whole product from chip to system, then the benefit will be that we will create not just a product for India, but a product for the world. And that is really what we should be doing. We should use, as Sanjay said, let's use India as the domestic opportunity and then create a world-class product for the world market. So let's not just aim at India, we should aim at the world. And then the size of the business becomes much, much larger. We're no longer talking about 10 billion, we're talking about 100 billion, 200 billion. So suddenly the scale changes. So that's really what we need to incentivize our teams of designers to actually develop and create a product which would be of great value globally.
Satya, if I may just add one point to what Ajay said in the Akash learning, since I was also aware of some of the details, is I think as a country, as a nation, we should get away from the infatuation, if I were to say, of getting something absolutely cheap. I think we should change the narrative to have highest value for money. So, for example, it's okay to pay $2 extra to a product and make it the highest value for money in terms of usability, rather than striving to say we'll take the cheapest product in the world for something. So I think that subtle difference between being cheap versus being highest value for money, that difference, I think, as a nation, we need to come up when we start to create products for India and for the world. Otherwise, we'll be narrow focusing on only one dimension of the optimization, which normally will not give you the best results. I'm sure, Satya, probably you can agree with that as well.
Absolutely. I'm not commenting, I'm just asking questions. So, Amrit sir, I think in your ecosystem, there are basically many players or your peers and friends who have created a good value proposition in the metering industry, right? People like Genus, these things, they are basically from your region. So how do you see the opportunity of doing basically all the way from chips to system in the metering industry? Because that smart meter volumes are generally talked about is 250 million meters in next 5 to 7 years, right? So do you want to comment on basically that opportunity?
Yes, but again, we come to the same point. Two things have to be really looked at very seriously. Number one is that the design, we have to create the design capability right from that chip level. Most people borrow designs either from China or from Taiwan or from Korea, and they try to copy those designs and make smart meters accordingly. But if we were to have an ecosystem developed for designing the meters around some of the chips that we know are very popular, and create that design infrastructure, then of course India would be able to not only self-reliant, but there could be a exporter for meters for the world. That is point number one. And point number two, I again go back to the question of the infrastructure for the components that all go into, whether it is meters, whether it is set-top boxes, or any other products. Unfortunately, we do not have the component ecosystem that is highly desirable. And therefore, of course, the government has recognized it, but the government has to come out with a PLI scheme. They have announced some more PLI schemes. But what the point that I think decision makers are missing is that they are focusing on large champions, as they say. They want to create large companies, large players. But in the process, we are ignoring the MSME sector, which is very, very necessary. We have to, give adequate thrust to the SME sector, because they will, contribute to this chip to, systems manufacturing. If these, the world over, the component industry, the electronic component industry is really actually driven by, or the subsystem manufacturing is driven by the MSME sector. And if we have a vibrant MSME sector, then we will also be able to enhance our exports. So we have to have an overall macro approach to the nation building in terms of electronic manufacturing.
Sure. So let me ask you another direct question, because you have basically proposed to set up the ATMP facilities in India, right? Suppose what Sanjay was talking about a chip on chip, or what Ajay was saying about basically a tablet chip, or for a smart meter chip for that matter. If we create the chip and the wafer, will you be ready to package them?
Oh, yes, absolutely. I mean, that's what we have gone on this ambitious program. We are, as you perhaps know, we are, approved under the PLI scheme for this ATMP project. And if, the chips or wafers, they are available either from India or from overseas, we would be able to package them to meet the needs of whether it is the telecom or tablets or notebooks, or even solid state drives, which can go into storage devices. So we would position ourselves for that, and we would go up in the value chain. We would start with initially probably low products like weather applications like pen drive, micro SDs. We could go up the value chain by going into systems and packages, and multi package systems over the years.
Sure. Okay, thank you. So shifting a gear a little bit, like there is a lot of talk now about basically products in the power electronics area, while telecom remains one of the premier segments, right? Power electronics get used into mobile chargers, to laptop chargers, or anywhere where basically AC to DC conversion needed. And basically electrical vehicles as well as basically telecom based station as a power amplifier or radars, basically where that gets used as a power device, right? So what do you think of a possibility of doing the semiconductor manufacturing of power electronics devices, either it's based on the GaN technology or silicon carbide or basically something like that? Because as everybody has said, that basically taking very large projects of billions of dollars of semiconductor manufacturing, while we are working on it, it might take basically some time. So in the meantime, should India basically invest in creating a semiconductor manufacturing of power devices, which might be possible to do in somewhere between like 100 to 150 million dollar of investment, or maybe sometime even lower? So do you think that is some right thing to do? And if we have to do it, what will be the model to do it? Because we still have to find out some basically person who knows the business of power electronics to drive it, right? Both whether it's needed, and second is how do we do it? We can start with Ajay sir and then Sanjay.
That's a huge, huge opportunity, and that's something that is looking like an imminent requirement for India and the world. And if we want to look at chargers, for example, and if we could use GaN technology to reduce the size of the charger, then it's a terrific product to have for us. And second thing is that that kind of a product is, to my mind, a need for the whole world, because the current chargers are really, really very ugly and big. And I think if we want to really do this in the country, we should not just look at doing the semiconductor in the country, but we should also look at people who've done it before and try and get some of those NRIs to come and move to India. And some people who actually understand this area to make it happen much faster. I think that is what is more important, because our knowledge will be very limited today. And we don't want to be just dependent on academic knowledge here. We want to be dependent on commercial knowledge. And I think that is really what we should look at doing, getting the right people into the country and having to start this silicon foundry. I think it'll pay for itself very, very quickly.
Sanjay, for Tejas, you were able to find a Desh. How do you find Desh of the semiconductor?
By the way, it's actually simpler than that. So if I were to say, just take from what Ajay is saying, and what you mentioned, Satya, earlier, see the amount of investment. So first of all, the business opportunities insanely large. I mean, just for India and for the world, it's a very compelling business case. So I was actually going to throw something more simpler here. We don't need to look for anybody outside of India. Outside of India is for the expertise. But as far as money is concerned, I have a few thoughts. I was just thinking, as Satya was mentioning, there are two options the government of India can do. Number one, let's say there are two companies in the public sector, NTPC as well as BHEL, who are experts in power electronics. The fab can be $150, $200 million is peanuts for government of India to set a gallium arsenide fab in any of these two entities, run by these two entities. So you take care of the big capex first. Then I will tee off on the point that Amrit mentioned earlier, that there is enough MSMEs, enough startups who can easily design the best charger for the mobile phone, the best chargers for the EV, the best chargers for all the home devices, etc., etc. You don't need a rocket scientist to design a very efficient power electronic charger. So that's the second part. And then the third thing I was going to say is there is another aspect which we can use in the power sector. Since you mentioned power electronics as an area of expertise, why just stop at the gallium arsenide, which will take, let's say it takes 12 or 15 months to get a fab going, right? Today, the electromechanical, which is transformers, your core, your inductors, and your bare PCBs, which are typically 4-layer PCBs that you need in a power thing, and the casing. 50% of the value addition of a power electronic device, whether it's a charger, can be done today without any headaches. The remaining 50%, let's start off on a project to basically get the fab by one of these guys. And then get the startup the incentive to invest in R&D. You really should be thinking of design-led manufacturing. Give an incentive to the buyer to buy all of this stuff. And bingo, as Ajay said, it's not a 10 billion opportunity, it's a 100 billion opportunity, easily tractable. So what is needed, Satya, just to simplify, and you took two good examples like the BharatNet and the telecom example. We took a practical power example, and Amrit talked about how, we should focus on what we can do today with the resources and the assets and the policies available today. What is needed is government to really have a very open dialogue with industry stakeholders, not just academicians who can make things happen. Listen to them, actually follow their recommendations, and with very little money, you can get all of these big opportunities. So instead of imagining and thinking about, okay, well, how do we create this $400 billion industry? Break the problem into two little problems that you devise: smart energy meters and power electronics in the power sector and telecom sector. Both of them are strategic. The money required is very little. The policies are in place. We just need the ecosystem to be fired, put a mission under someone in the government of India whose personal objective is to drive all the ecosystem holders to work together. And I can tell you within 12 to 24 months, we'll get the results.
Yeah. So, just 1 minute, Amrit sir. See, all of us know that we have tried these things basically for many, many years, right? Now, for the GAN fab or power electronics fab, all the money and all those things I just said can be arranged, right? But time to time, we did not make the required progress because we did not have the right champion who knows the business of semiconductor, not just technology. Technology can be basically bought from iMac or basically TSMC. A lot of people are ready to sell the technology, but in the past attempts, we did not have the right leadership who can create basically a business case or run the business of a semiconductor or fab. So do you have any specific suggestions? I think we can talk about it forever, but just like basically what Desh did for Tejas, right? Is there any Desh who can do the same thing for semiconductor industry?
Well,
I'm sure there are enough Indians of capabilities available. We just need to find them.
Yeah, and Satya, if I can come in now, what I would like to suggest is, we have to make a start somewhere. Every time we start talking about a fab, people say, oh, why go in for an 8-inch fab, or why go in for, the larger size thickness, that is, why look at 150 nanometers or 200 nanometers? You should, the world is going to 3 nanometers or 5 nanometers or 10 nanometers. So they start to discourage you in that direction because, a 10 nanometer, 15 nanometer, 12-inch fab may require an investment of, 10 to 15 billion dollars. While, as you rightly said, a low end, fab, particularly for power semiconductors, start with, 8-inch fab with maybe 200 nanometers to begin with. I mean, that is adequate to start with.
Yeah, so Amrit sir, what we are advising to the government is don't look at basically the technology in the fab. Look at the application of the output which comes out of the fab, right? So power electronics fab could be even 6-inch wafer, right? That is fine, right? Basically, and that kind of the investment. So as long as the output of that basically fab can be used for a meaningful application, like basically power electronics in this case, right? And I think government is getting very aligned to that fact is that let's look at the application of the output which comes out of the fab, right? So I think you are absolutely right. Let's not get fascinated by 2 nanometer, 3 nanometer, 5 nanometer. Let's look at how we can utilize the output of the fab to create a large business opportunity. I think that should be the motto. And that will take out basically academic studies about the fab and all those things. We should do that. It should be business driven basically opportunity, and that's why this whole discussion about the power electronics and the telecom, because it has application in every area. Right? And other products, if we have to do like a metering chip or a tablet chip, we can very happily fabricate it outside. There's no problem, right? Basically, as long as we own the product, right? It's okay. Basically, Qualcomm also does not fabricate in US; they fabricate in Taiwan, right? And they become such large company, right? So any before we wrap up in next 5 minutes, maybe just general comments from three of you in how do you, rather than being fascinated with fabs and all those things, we have to make India as a product nation, right? And these products basically, whether in telecom or metering and all of those things, can become basically something which is practical, where the it's not required like 5 to 7 years of R&D. These type of the products from chip to system can be created with reasonable investment in 3 to 5 years max, right? So any your views and vision and direction for these things, and we can start with Ajay sir, then go to Amrit sir and Sanjay to conclude.
I don't think we have to do everything at the same time. We can easily decide what to achieve in year 1, year 2, year 3, year 4, and year 5. And as long as we have the right direction and the right mindset, we can do it. The second point is that always we've had this issue: how will we start? How will we get it going? Will the government support? I think all of that needs to be put aside. We also need to, as an industry, that we are going to do a few things on our own. So if we want to get the first few products going and create it as a reference, let's get going as an industry, and let's put the best foot forward in putting all this together and making sure that we can tell the government, yes, this is feasible. Because sometimes, this whole issue has to be taken up rather than just waiting and waiting and waiting it out. Next scheme of the government, next strategy of the government, etc., etc. Let's just do something on our own as well.
I really appreciate the thought, right? I think we have to basically see how we can do this projects with just basically industry with not really 100% depending on the government support. Sir?
Yeah, I would just make two quick points. Number one is that we have to focus on exports. There is tremendous potential for exports, and mainly in the component sector and the EMS sector. We should take benefit of that opportunity, or the scope that is there. I'll just give you a very quick example. The example that I'd like to give for the PCBs, the largest PCB company in the country, they export 100%. And so that we have the capability, we are competitive. But the only thing is that because of the ITA ban, because of vested interests, that industry, the component industry, perhaps is not allowed to flourish. So that's point. And point number two, I think we should give focus on skilling for new age technologies. Like we talked about ATMP or about fab, or some of the IoT projects or artificial intelligence kind of products or devices. We do not have adequate skilling infrastructure in that direction. We have adequate skilling infrastructure for service jobs, but we do not have adequate infrastructure, skilling infrastructure for manufacturing jobs, particularly for these new emerging technologies. And that's where some of the focus has to shift.
I just have two comments in the closing. Number one, I would say, as Ajay mentioned, that we have talked enough. There's a need and a reason to start today with what we have. So like in a typical sales organization, we say, don't find the 99 reasons why you can't sell. Find that one reason that you can sell. So I think India has to start believing with the mindset that we can do it. We should do it. We are capable as a country, and it will be a national tragedy if even in the current geopolitical situation, we don't do all the things which we are ready to do. So that's number one, that the mindset has to change. The second point, which I would like to highlight, which I think, again, some other speakers have said, is that it has to be industry and business led. There is no point having anything which cannot create economic impact to the country. I mean, if nobody is going to make money, if country is not going to benefit, nothing will happen. So let's really not have any distrust or mistrust for private sector industry leaders who are willing to step up to the plate and get this done. And then the third thing, as I said, is there is no need today to invent or come up with any new policy. The government policies, the schemes, all those are in place. Please make them friendly and useful enough for what requires to be done. I think the ecosystem is there, the need is there, the business interest is there, the will of the government and the will of the entrepreneurs of the country has to align. And with this, I can tell you, we all keep celebrating the IT services story, which is a $150, $200 billion story. This is one sector which can create equal size, if not larger, economic impact in the next 3 to 5 years. This is an opportunity the country cannot afford to miss. The ecosystem is right, the people are right. Just trust the industry to do the right things, give them the support they need, fine-tune the policies, do it soon, and start right away. That's all I would say. And we really have this fantastic opportunity ahead of us.
Thank you so much. I think we'll conclude with the basically remark that all three panelists are very successful business people in this sector. They have created basically large organizations, successful financial organizations. So when we put something together, we'll look forward to contribute your share of basically money to do it in the private sector, right? Just putting you on the spot, but thank you so much. I think it has been very, very good discussion, but I think the time has come to do it, not just talk about it. And I think within basically next 1 quarter, we should be able to put something together with help from all of you to drive a couple of products in this direction. As sir said, start with a couple of things which are of the importance and then take up the others. And we'll require support from all three of you as industry leaders as well as others who are listening to it. Let's together make it happen. Thank you so much.
Thank you.